Assalamualaikum and salam sejahtera. So for today's lesson, we are going to learn chapter 1, which is functions. So for today's video, I will cover subtopic 1.1. So for our first subtopic 1.1, the lesson that we need to know is what is function. Function means relation or relationship, and when it comes to relationship, we usually knows that relationship involve two parties related to each other. Okay, now lesson number 2, how to explain functions by graphical representations and notation. Okay, for a better understanding regarding to functions, functions can be represented by arrow diagram, ordered pairs, and also graph. Okay, now we go through arrow diagram first. Okay, look at here. Okay, this is the first part and this is the second part. Okay, 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 4. Okay, 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 4. Okay, based on this part and this part, what is the relationship between both of these? 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 4. So we can guess that 1 plus 1, then you got 2. 2 plus 1, then you got 3. 3 plus 1, then you got 4. So the relationship between 1 to 2, 2, 3, 3, 4 is plus 1. Okay, so we double check 1 plus 1. So we got 2. 2 plus 1, we got 3. 3 plus 1, we got 4. So the relationship between this part and this part is plus 1. Okay, this is a relation lah. Okay, now. Okay, so this part we call as object. And while for the other part we call as image. Okay, so object can be represented as X, and then for image can be represented by Fx. Okay, remember that object represented by X, image represented by Fx. This one is the object, this one is the image. So how we want to write the function? So to write the function, we need to do like this. Function f of x is equal to, for function, we cannot write plus 1 only. We need to make an equation. So the equation is like this. Function of x is equal to plus 1. No, I already told you that this object represented by x. So x plus 1. This is how the equation. Okay, the equation, this is what we call as function notation. Okay, this one what we call as a function notation. This is how you write the function. Okay, or we can write like this, but it is also the same thing. Function f maps x to x plus 1. Okay, this is the other way on how you write the function. This is the first one, and then the second one. This is all the same thing lah. How you want to read? Function f of x is equal to x plus 1. And then for this one, how you want to read this one? Function f map x to x plus 1. This is how you write the function. Okay, so based on the arrow diagram, we can conclude, we can make a general conclusion that function is a special relation where each element, which is the object, is mapped to one and only one element, which is the image. So this is the general conclusion regarding to function, which is function is a special relation where each element, which is the object, is mapped to one and only one element, which is the image. Object cannot form more than one image. If there is more than one image, then we can't consider that one as a function. Okay, so now we already know how to represent function by arrow diagram. Now by ordered pair. So how to write the function by ordered pair? So this is how you do it. Okay, first you need to write curly bracket, and then okay, 1 map to 2. So 1 map to 2, 2 map to 3, 2 map to 3, and then 3 map to 4. And then close curly bracket. This is how you represent functions by ordered pair. So this one is object, this one is image, this one is object, and this one is image, this one is object, and this one is image. So okay, done for ordered pairs. Now we go through for graph. Okay, how to represent functions by graph? Okay, we know usually graph have two axes, which is x-axis and also y-axis. So we do it like this. Okay, so this one is the x. This one represent, for x-axis we represent as x, which is the object. And then for y-axis we represent as the image. Okay, now image represented by fx. Remember fx, so you write fx here. Okay, now the scale dekat sini. Okay, now object 1, 2, 3. So 1, 2, and 3. Okay, now for image 2, 3, and 4. And then 2, 3, and 4. Okay, so you map this one lah. Okay, 1 map to 2. So 1 map to 2. So here 2 map to 3 here. And then 3 map to 4. So here you do it like this. Okay. Okay, so done for graphical representation and notation for functions. Okay, we continue for lesson number 3. How to determine whether a relation is a function. Okay, we can look at example 1 in your textbook, page 3. But before that, how to determine whether a relation is a function, you need to remember the definitions of function. Okay, look at here. Function is a special relation which is each element, which is the object, is mapped to one and only one element, which is the image. Okay, so now look at example 1. Okay. Okay, for example 1. Okay, for example 1, are the following relation a function, and then they can ask you to explain. Okay, look at A. This is the arrow diagram, right, that I already told you before this. Okay, so now look at A. A, 2 mapped to 8, 5 is mapped to 2, which is the image, and then 6 mapped to 24. So for A, this relation is a function because of what? Each object has only one image, even though element 22 has no object. So if there is no object, it doesn't matter as long as all the object here have only one image. So this one is a relation, so this relation is a function. Okay, now look at B. B, 4 map to 2, 8 map to 2, still one image. And then look at 18. 18 is mapped to 3 and 9, which is more than one image. So this is, we cannot consider, this relation is not a function because it does not satisfy the condition of being a function. That is, each object has only one image. So, untuk for the relation to be a function, it must produce one image only. But for this B, it produce 18 produce two image. So this relation is not a function. Okay, now look at C. C, 1 map to A, one image. 3 map to B, still one image. 7 map to B, still one image. Okay, so far this relation is a function. But look at 9. 9 is the object, but it doesn't have the image, right? So it doesn't have the image. So remember the function, the definition of function. Each object must have one image. Means that all the object here must have the image. So if 9 doesn't have one image, so this C is not a function. Okay, remember? Okay, so C is not C is a relation that is not a function lah. Okay, now look at D. Okay, D. A is mapped to 4. Okay, one image, correct? Okay, now B is mapped to 4. Okay, good, one image. So it's still a function. C is mapped to 12. Okay, so it is one image. All the object here already have one image. So for D, the relation is a function because each object has only one image, even though element 10 has no object. Okay, boleh? Okay, continue lesson number 4. How to determine whether a graph of a relation is a function. Okay, to determine whether a graph of a relation is a function, we use a vertical line test. Okay, what is vertical line test? Vertical line test is straight line like this. Okay, it's okay. Look at example 2, textbook, page 6. Okay, now, look at this one. Vertical line test. Okay, if the vertical line test cuts only at one point on the graph, then the relation is a function. Remember that one? But if the vertical line test does not cut the graph at any point, or it cuts more than one point, then the graph is not a function. Okay, clear, eh? Okay, vertical line test. If the vertical line test cut only at one point, so the relation, so the graph is a function. And then if the vertical line test does not cut the graph at any point, or it cuts more than one point, then the graph is not a function. Remember that one? Okay, now look at example 2. Which of the following graph represents a function? Okay, so this one, look at A. Okay, this is this is the vertical line test that I have drawn. Okay, so this is the vertical line test. Okay, it cuts at one point. Okay, this one also it cuts at one point. So this one we consider as this graph is a function. And then look at B. Okay, I already draw this one. This is the vertical line test. So it cuts at one point. This one also it cuts at one point. This one also at one point. Actually, at any point, if we draw the vertical line test, it will cut at one point only. So we can consider this one as this graph is a function. Okay, now look at C. Okay, if we draw the vertical line test on the y-axis, it cuts at one point, right? So maybe we can consider this one as a function. But if you draw the vertical line test at the other part, which is if you draw the vertical line test here, it cuts at 2 points, so more than 1 point. So it means that this is not a function. Boleh? Okay, we continue our lesson number 5. How to determine the domain, range and codomain. This is the 3 terms that you need to remember. Okay, so we can look at the example 4, textbook page 8. Okay, now look at example 4. Determine the domain, codomain and range for each of the following function f. Okay, so look at here. Okay, this is the question number 1, question A. Okay, now domain. The domain is all the object here, all the object here. Domain is all the object. Remember, domain is all the object. So P, Q, R, and S. So you need to write like this. This is the curly bracket. So do it like this. Okay, now codomain. Codomain is all the image. Include the one that doesn't have the object. So this one, all this one. So 1, 3, 4, 7, and 9. Alright, okay, now the last one for range. Range is the image which have the object only. Okay, remember? Okay, ingat range is the image that have the object only. So 1 ada image, ada object. 3, there is an object here. 4, it doesn't have the object, so 4 cannot be included as a range lah. So 7 have object, 9 has object. So 1, 3, 7, and 9 is range. Okay, for example, for B, the domain of B is, ingat, remember, domain is the object, which is the x-axis. So domain of this one is -2. Look at the dotted here, -2. Okay, so you can write like this, -2, and then you see dotted here, so this is 0, and then 2, and then it is in between 2 and 4. So we know it is 3, and then the last dotted here is 4. So the domain of question B is -2, 0, 2, 3, and 4. Okay, and then close bracket. Now for codomain, remember that codomain is the image. So if it was in a graph, codomain or the image is at the y-axis. So at the y-axis, look at here, the first dotted here, y-axis. We look at the y-axis, which is the fx. So y-axis, the dotted here is, we don't know this one, but it is between 0 and 2. So this is 1. And then the codomain is 1. And then the second one, the dotted here is 3. Okay. Now, the dotted here is 5. Alright. And then this one is 2. And then this one is 4. And then this one also 4. Okay, so we don't write the element or the image 2 times. Just represent as one. This one lah, just 4 only. No repetition. Okay, so this one. Alright, so the codomain is 1, 3, 5, 2, or 4. Or you can rearrange this one to 1, 2, 3, 4, 5. Either one, as long as all the element of all the image here is all the image is in here. So for range, okay, remember range is in the image that have the object. Okay, look at the range. So this one, okay, range is the image which have object. So we know it is, okay, what, this one is 1, and then this one is 3, and then this one is 5, this one is 2, this one is 4, and this one also 4. But we write it we write 1 only, which is 4 only lah, no repetition. Okay, so that's it for range. 1, 3, 5, 2, and 4 also, same as codomain. Okay, now look at C. Okay, now look at C. The domain, as usual, it was in the x-axis, which is the object. So if you look at this graph, this is the graph, continuous graph. So we need to remember that each of the point here is the object. So it is different from this one because there is discrete graph, but this one is the continuous graph. Okay, so for this one, this is the continuous graph, so you need to use the symbol of inequalities. So how is it? Now the image, the domain of f ni means function, domain of function f is x is in between the lowest value of x is what? 0, which is equal to. Okay, and then the greatest the greatest one is 3, so 3 here. This is for domain. And then for codomain of function f is, okay, codomain, remember that codomain or image, we represented that one as fx. So fx, look at the lowest one, which is 0, greater than or equal to 0. Okay, now the most highest value is 6. So 6 here, like this. Okay, now for range also the same. We can consider that every each of this point have object and its image. So we can just copy the codomain like this. Fx greater than or equal to 0 but less than or equal to 6. So this is the answer. Okay.